Because warm fronts tend to happen at a much lower angle, they're usually associated with precipitation over several days. So the weather pattern you would experience, you would have colder temperatures followed by light rain and then warmer temperatures. A cold front cold front is the opposite of a warm front. You have cold air that moves into warm air. And if you notice in the diagram, this happens at a much steeper angle. So what happens is you get these really tall cumulonimbus clouds. That warm air, because it's less dense, is going to rise. So you have warm temperatures followed by faster, heavy rains and storms. And then you're going to have a period of colder temperatures. So cumulonimbus clouds are the vertical clouds that are usually associated with thunderstorms. So a lot of times you're going to have higher wind speeds, heavier rains, but they're going to move much quicker than our warm fronts that tend to last for several days. A stationary front is simply when you have a warm air mass moving into cold air or cold air moving into warm air, and the air masses stay stationary. So right where the two air masses meet, or that front, you're going to have precipitation. And a lot of times what happens is you have cold air moving in one direction and warm air moving in the other. So instead of overtaking each other, that boundary or that front between the two air masses stays in the same place. So you're still going to experience precipitation, but similar to a warm front, it's going to be a little bit slower. You're not going to have the heavy rains and storms like you do with a cold front. The last type is an occluded front, and that's when a cold front overtakes a warm front. Usually cold fronts move a little bit faster, and so they can catch up and overtake a warm air mass in front of them. So what's going to happen here when this cold front catches up, the warm air is going to get cut off from the ground, or occluded. So here's a profile view. You've got your cold air mass overtaking a warm air mass, and that's your cold front. Here you have the warm air mass overtaking cold air, that's your warm front. Because the cold front is faster, it's going to catch up, and that warm air is going to start to get cut off from the ground. So when the cold air catches up, you're going to have heavy rains, and then it's followed by lighter rains as that warm air rises and forms clouds and precipitation. You've probably heard the term humidity when you're watching a weather report, or we talk about that a lot in the summertime here in North Carolina. Humidity deals with the amount of water vapor in the air. When it's given as a percentage, which is what we usually see on our weather reports, that's actually the relative humidity. It's the amount of water vapor in the air compared to how much it could hold at that temperature. Higher temperatures can hold more water vapor, so that's why it tends to be more humid in the summertime. Whereas the winter, colder temperatures can hold less water vapor, so the air tends to be dry. So relative humidity we do express as a percentage. So if we say that the humidity is 70%, that means the air is holding 70% of the water vapor it can at that temperature. In addition to temperature, there are other factors that come into play: air pressure, the availability of water vapor, but usually we compare it to temperature. Now we've talked about fronts and how when that warm air rises, we form clouds and have precipitation. At any given time, due to the water cycle, clouds are going to cover about 40% of the Earth, and that's why when we look down from space, we see the blue and the white. Clouds help reflect sunlight back into space. The amount of light that something reflects is known to as its albedo, so clouds have a high albedo. If we did not have that 40% cover of clouds, the Earth would absorb about 20% more heat from the sun, so our temperatures would be even higher than they are. Now at nighttime there's the opposite effect. If it's cloudy at night, the temperatures tend to be a little bit warmer because it traps that heat that's been absorbed by the Earth's surface during the day that usually would radiate back to space. So here you see without clouds that heat rises, but with clouds that heat is trapped. So pay attention this winter. If you have a clear night, you'll notice it tends to be colder. If you have a cloudy night, it tends to be warmer.